Good day, YouTube. Today's recording is going to focus on F5 IngressLink. I have recorded and documented a few other F5 IngressLink videos that you will find on my YouTube page. But what's really cool about this video is the new features that have been added to the F5 IngressLink solution. And we're going to get into some of these new features. We're also going to talk a little bit about why IngressLink. And what's really interesting is we've released F5 IngressLink now to the market for about 10 months. I am starting to see more interaction. I'm starting to see the community like what we've done and deploy F5 IngressLink in their environment. And I think that there's a lot more that's going to come around this space. So let's get into this. So this video today is really focused around F5 IngressLink with external DNS. So what is F5 IngressLink? Well, IngressLink is a solution that really delivers this whole modern application story around scaling, also with addressing and resolving some of the persona challenges. And we see some of the persona challenges when communicating with different clients around the world. And so F5 IngressLink is really, think of it as a common resource, utilizing the common Kubernetes API between BigIP and nginx. So there is development that has been done between BigIP CIS and nginx-ingress controller that allows both the two controllers to communicate via this common resource definition or common API. With IngressLink with external DNS, it now allows application developers to control DNS records dynamically via Kubernetes. So not only are you potentially providing a public IP to ingress traffic into the cluster to nginx-ingress controller, but now potentially bring up something like a active-active or potentially maybe even something like an active standby maybe in the future. And then manipulate that DNS record based on an external DNS CRD. Let's get into that a little bit more. First, people ask me, Mark, why IngressLink? Well, the great thing is that IngressLink is a fully supportable solution that integrates BigIP and nginx technologies. It's really built again for this modern container application workload using BigIP, CIS, and nginx-ingress controller for Kubernetes. And what's really elegant is this elegant control plane solution, I think, that offers really this unified method of working with F5 technologies. And you can really see what is this control plane solution. It's really the Kubernetes API, right? And this common resource definition that interacts with this Kubernetes API. Single interface, right? That really offers best of what BigIP and nginx can foster, right? And collaborate really between the different personas or the different groups. And your groups might be somewhat named quite differently, but this is really taken from the Kubernetes SIG, where we talk about some of the networking functions within Kubernetes. And so, this cross collaboration between infrastructure providers, maybe those are your BigIP NetOps administrators, the cluster admins, maybe that is a group of somewhat administrators that work with both BigIP and maybe Kubernetes, or just the operators, the groups that actually bring up the operators that somewhat have a little bit higher administrative rights, maybe into BigIP as well as Kubernetes. And of course, application developers, these are DevOps folks that simply just manage the container pods that are running within Kubernetes and that are creating the ingress resource definitions or the ingress classes specifically that interact with Kubernetes. So if you look kind of here, Big IP is really your infrastructure provider. CIS kind of dabbles a little bit between Kubernetes and cluster operators, where nginx is really focused here on the application developer side. And so that's what's really cool about IngressLink, is it kind of works very well with these personas, and it kind of aligns quite well. And that's really why I think this is beneficial, because aligning the priorities with potential minimizing conflict between teams and enabling this multi-tenancy type approach within Kubernetes. Therefore, saving and reducing time with reducing errors with a declarative deployment that interacts both with Big IP and nginx. And so you will see that with IngressLink, we've simplified the IngressLink resources, and specifically the CRDs. It's way simpler. We've added a lot of the defaults. If you require customization, it's not necessarily IngressLink. IngressLink is cloud-like simplicity that minimizes a lot of the configuration aspects. And so you have to look at it. Do you want to take something more vanilla, cloud-like ingress approach, or do you want to customize and add every single specific object that's available? And if that's the case, then IngressLink is really not for you. And there are other solutions with using virtual server CRDs or transport server CRDs with external DNS CRDs as well. So it really depends upon your level of how simplicity you want to remain. So here is the architectural diagram that we're going to focus on today. And so this is what this user guide really talks about. It talks about IngressLink with external DNS using Big IP, LTM, and DNS, with CIS to provide automation of LTM and the DNS functions, working with nginx. So you can see here the Big IP. This is the Big IP local traffic management that provides ingress traffic to nginx ingress controller. And then, of course, also this is the DNS functionality that provides geographical load balancing between clusters, between sites, between locations. In this instance, I've only created one cluster, one Big IP, but you can create multiple clusters. I have lots of videos, and I've just published a video with 2 clusters, one OpenShift, one Kubernetes. You can use this exact same deployment in that environment, because the wide IP is what's common between the clusters that provides the load balancing between the clusters. So what you can also see here, we've got, in this case, it's just 3 nginx ingress controllers. So these 3 nginx ingress controllers will be part of the Big IP pool members, and all the traffic that comes into this virtual IP will be forwarded to these nginx ingress controllers that will then get routed between either Coffee service or T service. This is what is going on here with this Cafe ingress service. It's the HTTP routing between the two pods, between these 2 services. What's also interesting here is that the administrator will create this IngressLink CRD. This IngressLink CRD is what's going to put the public IP on Big IP, and I'll show you that in a minute. And this external DNS CRD that's going to configure the DNS wide IPs. And so CIS is automating both DNS and Big IP on the same device or different devices. It's really your choice. So pretty cool architecture. It's potentially maybe a 2-3 level architecture, depends upon how you classify your DNS, whether your DNS is on the same device or off the device. But let's call it a 2-tier architecture. Your first tier is your infrastructure tier, potentially managed by your NetOps group, and your second tier is your DevOps tier. And we're bringing them both together to provide a solution that really scales well. So scales well on the control plane, scales really well on the data plane. And you can obviously scale as many potential resources as you need here, which doesn't necessarily affect any of this front-end traffic because they're completely decoupled. And that's one of the reasons why I think the IngressLink solution is definitely one of the best solutions that I've been working on. So let's take a look at some of the configuration aspects here, and we'll go through it. So couple things that you need to do to configure. There's a couple of steps here. You can just follow the steps. Enabling some of the iRule on Big IP for proxy protocol, installing CIS, installing nginx-ingress controller. So you can kind of run through these examples on how to install CIS, how to install nginx-ingress controller, installing the cafe application. This is so you have the application that's installed, and then of course creating the ingress resource for the cafe application so that Nginx can load balance to the pulse. So that's jumping through a lot, but we've talked a lot about bringing up about configuring CIS and configuring Nginx from the manifest files. But what I want to go into here is focus a little bit more about what's new here with IngressLink and external DNS. And so what I've done is I've mapped these two together. So the public IP and the host. These are the most important things here. This public IP, it's either provided or it's pulled from IPAM. That's your choice, right? You can also use this IngressLink CRD and pull a public IP from IPAM. In this case, I provided the public IP. This is going to be the virtual IP address on Big IP. What's new here is the host. The host, this is the FQDN that we're going to create as our wide IP that is going to provide the potential load balancing between the sites. And so what really needs to happen is this host, cafe.example.com, needs to be the same as the domain name, because that right there is my wide IP. And this is the namespace Nginx. Try keep these default. If you keep these default, it's going to be simple. What's also important here is I'm creating these objects in the Kubernetes data center plus server, right? What I'm also doing is I'm monitoring the applications. So as based on the diagram, I have two pods deployed, both tea and coffee, and I'm monitoring these deployments. So what's actually happening here is DNS is actually probing, using a DNS monitor, the status of both of these applications through Nginx ingress controller. So it's actually almost an end-to-end. So we'll make sure that if we can probe and connect to these backend apps, then the wide IP remains. Wide IP is removed if we cannot probe these backend apps. So that's an end-to-end DNS monitor. Communicate with your F5 solution architect or F5 sales engineer about scaling this, right? There is kind of a sweet spot and number as potential monitors and how many monitors you want to create, etc. But it is really important to have that conversation. On the other hand, the local traffic management, the monitors here on what LTM is doing is simply just monitoring Nginx liveness. And so that's the monitor that we actually monitor. We actually monitor the liveness. Let's take a look at that. So we can actually see that right now we don't have anything created. So let's go create that common CRD resource. And if we want, we actually looked at it right here. So this is the resource definition that I want to create right here with these two, virtual server and host. This is what I'm going to create, which equates to that. I'm going to create this in Kubernetes. So we'll do kubectl. If I just do an up arrow, there we go. That's the eDNS. Oh, actually, I deleted it here. Let's go ahead and create this. And this is the creation of the virtual server. And we should see that has been created. You can see right there, these two are created right here. What will actually happen is the monitor will actually come up. But we can see from the pool members here, we actually, in our case, I'm actually deploying 4 instances of Nginx ingress controller. And if you actually go, let's take a look at the monitor on here. We can see there's our monitor right there. And we can actually go to our monitors and actually scroll down and look at that monitor that was created. So if we look at the monitor right here, that's what I'm probing. I'm actually probing the Nginx ready statement to make sure that it's up. So that's actually kind of cool. So Big IP is making sure that the Nginx ingress controller process is up. based on the nginx ready, and that's how it's connecting to that. And so what you'll find right now is that we have our virtual servers configured for both port 80 and port 443. So locally, if you want to connect locally to this cluster, you can by this IP address, or if you want to resolve DNS somehow on a system where your DNS resolves to this IP, to that fully qualified domain name, you can connect this virtual, which means that you can connect to the backend. In my case, I cannot connect because my DNS server is delegated to the big IP, but I don't have a wide IP unless there is a cache. Let's take a look, cafe.example.com/t. Nope, it will fail because there's no DNS. There's no DNS there. Okay, no problem. So now that we have our local configured, we want to configure our wide IP. So there's no wide IP, but the data center is there. You can see the data center is there, and there's a server in that data center, which is the K8S, which is 2 virtual IPs. You can actually see them right here. There's those 2 virtual IPs. This is from discovery of the virtual servers through the GTM config. So now the next big step is to configure the wide IP to provide potentially active or a external DNS type configuration. So this is what I'm going to create next, cafe.example.com in that data center for these 2 systems. And you can actually see that DNS has failed there because my DNS server is delegated as a name server to the big IP, and there's obviously no wide IP there. So let's go create that wide IP. So kubectl create oopsie, why did I go -f, and that is edns-cafe. And so now I've created the wide IP. So you can see there is my cafe.example.com with my one pool member. That one pool member is my Kubernetes cluster in San Jose. And so at this point, I can connect to that Kubernetes cluster, and you can see right there, I've connected to that cluster, and I can connect to that cluster probably with HTTPS for coffee. So you can see right there, connected to the cluster. This is the remote IP. This is actually one of the nginx's that I'm connecting to. We can validate that. Yeah, 87. So if I go take a look at LTM and take a look at the pool members or the nodes, I can see that's the first one that I'm connecting to. So that's actually really cool. That's the first one I'm connecting to. And then if you look at the backend application, this is the backend application right here, 10.244.1.86. This is the T app that if I go to Kubernetes and do a look at the pod, kubectl get pod, you can see here that is there's 5 deployments of the pods there. I can look at those addresses I want. But Big IP provides load balancing to nginx, and then of course the nginx provides the load balancing to these pods. And so that's where that address is actually coming from right there. This is the IP address of the big IP itself, right? It's the internal IP address that was netting to. So that talks a little bit about this solution right here. You can follow this document here. This document kind of goes through some of the things that we kind of went through already. But let me go back up and recap. So what we just saw was the integration of F5 IngressLink with external DNS. And so external DNS adds the functionality of creating a wide IP on big IP DNS. And in this case, I'm just creating one wide IP, but you can create many wide IPs. You can create a per application. You can create one wide IP for multiple applications with potentially one monitor or multiple monitors. That's really up to you. So the limit that you want to do is up to you. That it's very, very, very flexible actually. I do have other videos that I've created that are on my YouTube page that talks a little bit about either per app failover using DNS or a single wide IP with multiple applications. I also have videos there with multiple clusters, with and without nginx. It's totally up to you if you want to go and load balance multiple clusters. But this is actually really cool. And so this solution is really built on top of what we did initially with IngressLink, and now we've added the external DNS functionality to it. And there's additional stuff coming in up-and-coming releases as well. Thank you very much. If you like this video, please like and subscribe. It kind of helps with obviously the YouTube algorithm. More people get to see the content, which is actually kind of cool. Have a lovely weekend. Thank you.